role. So whatever the concepts you have learned so far, like kind of this estimation problem, Bayesian estimation, maximum likelihood estimation, and all. I mean, these are the very important topics. Also, this will help you to understand the basics of machine learning courses. So, which you will find you'll be able to connect while you are going to move in machine learning foundation courses or machine learning technique courses. I mean MLF and MLT. So these are topics are going to be very helpful. Even all the things which you have done in stats one and stats two, that will play a very important role. Even this random variable will help you to understand the uh, you so far you have seen single normal distribution. In MLF and all, you will see the bivariate normal distribution and all. So these are things going to play very important role. So I hope you have learned something. Okay, so anyway, let's start the today's session. So I will quickly go through the, I mean, usual thing I will follow. I will quickly cover the concepts and then we'll try to solve some questions which have been already asked in your, previous year terms. Okay, one general question. So, is there any session going on along with this session, or this is the only session? Or after this, do you have any session?
After this, we have maths.
After this, you have maths, right?
Yes.
Okay. Okay, and we will try to finish. Okay, so first of all, I wanted to show you the formula set so that you can get an idea what are the things you have to memorize or not. Anyway, so this basic formula, there is no need to memorize it. These all things in your mind, that's better. Otherwise, don't worry about the things. So this for all the basic distribution, discrete and continuous, this along with the inequalities, the weak law of large numbers, CLT. Also, we have provided the this how to calculate the bias and method of moments. What is the likelihood, ML estimation. So this is not whole quiz, just to give you idea. The Bayesian estimation, then normal. Then we have given all the situations of hypothesis testing. You have seen that there are some test for mean. Then when sigma square is known, then there will be G test. Okay. So based on the different kind of alternative hypothesis, you will define your rejection region and accordingly your test. If variance is unknown to you, then you will go for T test. Similarly, if you want to test for variance, then there we have chi-square test for variance. So till this points, it's all about single sample. If you have two samples, then there is two samples Z test for mean, two sample F test for variances. So these all things will be given to you along with your question paper. Okay. So let's start the our session. So so I think the same concept I had discussed in week 11 solving resistance, but let me repeat. So in week 11 in week 11 and week 2, what is the key concept that is start that is called the hypothesis testing. Okay. But the thing is, we should know like what is the hypothesis testing, what is the meaning of hypothesis, right? What is the meaning of this word hypothesis, and what's the real life situation where you can use the hypothesis testing procedures and all. So I will write one scenario, then I will proceed further. So suppose, so hypothesis is nothing but this is a claim, or I can say this is a assumption. Okay. Or you can say this is any belief or something like that. So this is the claim. So you will make a claim and you are going to test that claim. So that's called hypothesis testing. So I will write the scenario, some 2 or 3 scenario, maybe that will give you a clear idea. So suppose, imagine, okay, so let's say you are, what to say, okay, let me write. Suppose you are know, owner of a manufacturing company. Okay. Let's say in that company, let's say in a manufacturing company, and which produce some, let's say, medicine bottles or something like that. Okay? So your company claims, I'm saying your company claims that each bottle, each medicine bottles, okay, weigh exactly, you know, let's say 200 ml, no, on an average. So 200 ml liquid or anything, just you can say assume this is just some any cup syrup or something like that. Okay. So but so there is scenario, but the customers or okay, so these customers have started the complaining about the variations in the, or I can say variations in amount of, let's say variations in weight, or you can say variations in amount of liquid in the bottle, whatever. So the situation is like there is a claim from your company. So what is that claim? Okay, that says each bottle weighs exactly 200 ml on average, right? But what there is something you are getting some complaints. Okay, the situation is then how can you verify? Okay, how will you verify if your company's claim holds? Okay, so this is where I will say this is where hypothesis testing comes into the picture. Okay, so are you getting this part? So situation is you are going to make a claim in general, okay, for a population part basically, and what is the thing then? The question is how will you uh, verify, how will you test your claim? Okay, so this is called hypothesis testing. Okay, so this can happen in lots of situations. Okay, so how will you define your this, basically how will you write your hypothesis? Okay, so there are two kind of hypothesis. First of all, called usually we are saying null hypothesis, okay, and alternative hypothesis. Usually we can denote HA or H1, that's not a problem. So suppose I'm taking a situation, let's say I'm taking a situation for a medical trial. Okay, so for this medical trial, so suppose there is a form, no, there is a company who wants to test if a new drug is more effective than the current current one. Suppose this is the situation. Okay, so what is the situation? A company, a medical company, okay, what he wants to test if a new drug is more effective than the current one or old one, whatever. So what will be your hypothesis basically? So your hypothesis or your claim will be like this: the new drug, let's say you can make the new drug is not more effective than existing one or current one, right? You are saying both are equally effective basically. Okay, what is the alternative will be hypothesis? The new drug is more effective. Yes or no? Are you able to relate? Right.
Yes, sir.
Now let me take some other example. Suppose uh, there is no marketing company, and that particular company wants to test whether a new advertisement technique increases the sales or not. So what will be your null hypothesis? You can make the new advertisement has no effect on sale. And what will be your alternative? The new advertisement increases the sale, right?
Yes, sir.
Okay, so another I will take one more example, then I will move on to discuss the another topics. So let's say there is a situation, I'm saying a factory checks if a machine is producing items. So this is a situation, okay, with a mean weight of 100 grams. Let's say this is the situation. So what will be your null hypothesis? Basically, what will be your claim? The mean weight is 100 grams, right? So this will be 100 grams. Maybe you have seen some problems. You will write mu is equal to 100, yes or no, right?
Yes, sir.
And what will your alternative? Mean weight is not equal to 100 gram. Okay, so it can change, right? It can change as per the scenario. So what I mean by change, it can be, let's say you want to test whether mean weight is more than 100 gram or less than 100 gram or not, right? Are you getting? Another, let's say if you want to test in field of education, then suppose situation is a teacher wants to know if a new teaching method is better than the traditional method. So what will be your null hypothesis now? Can you anyone? So situation is there is a teacher, he wants to know if a new teaching method is better than the traditional one. So what will be your null hypothesis?
Null
New teaching
hypothesis
method.
will be not better teaching,
Not as
and
effective.
yeah,
It's
not
basically new
effective.
method has the same performance as the with old method, right?
Traditional teaching.
Yeah, yes.
Traditional method.
Yeah.
Okay, great. And what will be alternative? Alternative will be new method improves the student performance, something like that, right? So if
Yes.
it improves
Yes, sir.
the student performance, that means you want to say the new method is better than the old one. Right. Okay. Suppose I'm giving you another scenario. Suppose there is a farmer, he tries new fertilizer and wants to check if it increases the
Sir,
yield of the
sir,
crop or not.
your screen is not visible.
So no, I think my screen is visible, but I'm not writing anything. I'm just giving you the scenario. So suppose, so I was like, so situation is there is a farmer, he tries a new fertilizer and he wants to check if it increases the yield of the crop or not. So what will be null hypothesis?
The yield is normal.
I mean, fertilizer doesn't increase the yield and
Yeah, yeah, yes. And then alternative would be it
it
increases.
increases the yield. Okay,
Yeah.
okay, great. Yes, yes, Lucky Sethi, do
Uh,
you any query?
yeah, sir. Is it necessary that null hypothesis is negative, like, and alternative is positive, or else
No, it's
can we
not
do it?
about, see, it's not about negative. It's all about the null hypothesis you want to make. You are, it's basically, uh, you can say you don't want to, you are assuming that is true. I mean, not what to say. Suppose I'm saying your claim is what? Suppose I'm saying your claim is mean weight is 100 gram, right? So the null hypothesis is the hypothesis with no difference actually. Okay, and alternative is the something which you want to test, just opposite to null hypothesis.
Sir, null hypothesis, we can
Okay,
say in simple words that the null hypothesis is a kind of hypothesis which can explain the population parameter whose purpose is to test the validity of the given experimental data.
Yeah, that's correct. That's not a problem. That's correct. So, look, are you getting my idea? So, null hypothesis is all about the hypothesis with no differences. Okay, alternative is with differences you want to check whether it's a greater than, whether it's a less than, or whether it's a equal to or not.
Yeah, sir.
Okay,
Thank you.
so that's the null hypothesis. So, in null hypothesis, alternative hypothesis only. So I will move ahead. So actually, in what is the in hypothesis testing? So you saw a claim. Okay, what is the usual procedure? You will, what you will do? I mean, you will verify with the help of sample data, right? Now, so there is something called acceptance region and rejection region. I mean, when you will reject or when you will accept. Okay. So I'm just writing null hypothesis. Let's say I'm taking a scenario. There is a, let's say we are talking about there is a, you know, unbiased coin. Okay. So what will your null hypothesis? Suppose I'm saying P is zero point 0.5. Alternative, I can define, let's say P is greater than 0.5. Okay. The thing is, what is the meaning of this part? So let me draw. So this is standard normal curve. So whenever you have to solve the problem of this hypothesis testing, at the end you have to convert your test statistics in standard normal form. Okay. So first of all, so this is what? This is right side tail. Okay. So what is the meaning of right side? So there is, suppose there is some critical value C. Okay, so if your null hypothesis like this, P is greater than some quantity, okay, then this is part where you will reject the case. Okay, so this is called rejection region. Okay, this is something also I can denote with the alpha. I will come to this part alpha. Okay, so if this is the alpha, so this whole things I can represent as a 1 minus alpha. Okay,
Yes.
so this is called acceptance region. So the thing is, if you see this null hypothesis, so this is, I'm talking about just a greater than part, right? So whatever the sample result based on the sample data and all, you will perform some, you will use some test statistic and you will perform the hypothesis testing procedure. I will do in a minute, but I'm just here. I'm giving you idea. So when you will reject your null hypothesis, okay, when the whatever the performance you did, let's say you have compared the x bar, then value of that x bar should be in this region only, then you will reject. Yes or no? Basically, let me say, you have seen the test statistics we are writing as a t. If t is greater than c, then I'm rejecting the null hypothesis. Are you able to relate?
Yes, sir.
Yes.
Right, suppose our null hypothesis can be something like this. So this is null hypothesis, and alternative hypothesis, suppose I'm talking about p is less than 0.5, then what will be your rejection region? So I'm very bad at drawing. Okay, so suppose this
P
is
is greater than 0.5.
greater than, no, not right, this is
Less than, less than.
right side tail, right tail test, right? If you say this
I
is
mean,
right.
rejection.
So here, suppose this is minus C, just for simplicity. Why I took minus C is because this is left to 0. It's not necessary, but yeah, let's say this is minus C. So this will be my alpha, right?
Yes, sir.
My rejection region. It will be clear in a minute. Don't worry why I'm saying this alpha and all. So if this is the alpha and area under curve will be 1. So this will be 1 minus alpha, right? So this is acceptance region. Okay. So if the value of test statistics, whatever you have calculated, if that value is less than this minus C, you will consider as a, and then your decision will be you are going to reject
Reject.
your H naught. Okay. Now, so this is called left tail test. Okay. So this is left tailed test. Okay. Now, situation is you will suppose null hypothesis is this, and alternative is saying you are saying P is not equal to 0.5. So in the previous two example, you said it's a greater than or it's a less than. But whenever you are saying P is not equal to 0.5, means this means what? It can be less than, it can be greater than, right? This means what? We are talking about two-sided tail test. Okay. So this means, so this is the G. Okay. Suppose this is your P this is minus c. So what so you can say this is not equal, so this means it can be greater than, it can be less than, right? P can be greater than 0.5 or p can be less than 0.5, right? So when you will reject your null hypothesis, so suppose there is a test statistics, so how will you decide? So modulus of t is greater than c or not. Basically, you will say if t is greater than c or t is less than minus c. Only then you will reject your null hypothesis here, right? Yes or no? So this whole thing is 1 minus alpha. 1 minus alpha is acceptance region. Tell me, uh, first of all, you can see here, this is the alpha rejection region. What should I write here?
Alpha by 2.
Alpha by 2.
Alpha by 2, right? Because this is total is alpha. So one side will be alpha by 2 in case of this two-sided tail test. Yes or no?
Yes, sir.
Okay. Now, I will come to next part. Okay. So that is called, that's very important thing, that is called actually, so you can make two kind of error in hypothesis testing. Okay, so what are those error part? Anyone, any idea, can you tell me?
Type 1 and type 2 error.
Type 1 and type 2 error. Okay,
Reject H naught when it is actually true and
yeah, that is
accepting
the
A.
alpha, that is the alpha, yeah.
And type 2 error is accepting H naught when HA is true.
Okay, let me
Yeah.
write, okay, something, let me write called size and power of the test. Okay, so this is the standard term. So what is the size actually? Okay, so size is nothing called level of significance. Okay, so this is called level of significance, and the note we are denoting with this is this level of significance as a alpha. So what is this alpha actually? So alpha is nothing but it's called probability that type 1 error. Okay, so this is probability of making type 1 error. So there are two kind of error, type 1 error and type 2 error. I will come to this point. So what is the type 1 error actually? So alpha is defined as nothing but probability that reject H naught when H naught is true. Okay, and the next thing is called beta. Beta is nothing but defined as a probability of type 2 error. And what is this probability of type 2 error? So beta is nothing but probability of you have basically accepting H naught when HA is true, means alternative is true. There is another concept called power of the test. Okay, so this power of the test is defined as a 1 minus beta. And what is this? Probability of 1 minus beta is what? So this is probability of accepting H naught given that H is true. Then it will be 1 minus of this accepting, that means probability of rejecting H
Rejecting
naught
H naught.
and when H
H
is
is true.
true, right? Now, so one more thing, usually we are taking, okay, so I will take some example, then you will tell me which one is the alpha and which one is the beta, right? So first of all, so actually what is the meaning of this? I'm taking alpha as a probability of reject H naught when H naught is true. What do you mean by this? Basically, this alpha represents nothing but the risk of making this type 1 error, right? Or you can say the probability of chance or percentage of making type 1 error, right?
Yes, sir.
Yes or no? So suppose usually we are taking alpha as a 5%. Okay, so 0.05, or you can say 5%. So what is the meaning of this 5% if alpha is 5%?
We can tolerate 5% of error.
Error. Okay. So basically I can write there is a 5% chance of making type 1 error, right?
Yes, sir.
But what is the meaning? What is the intuition? Can you think a bit?
We will accept H naught within the 5% error.
Okay, suppose I'm giving you scenario for you want to test for COVID-19 positive. Then what will be? How will you interpret this? What is the meaning of this 5%? Anyone, any thought?
Out of the 100 people, 5 people who are healthy are also tested positive for COVID-19.
Right? Correct. That's the probability of. So this is one kind of error. Means type one error. What is the type one error? It is given that H naught is true, but you have rejected your H naught. I mean, what will be your hypothesis? So you are saying that alpha is 5%. This means, what is the meaning of this? So this meaning 5 out of 100 people. Okay. Basically 5 out of 100 healthy people, no, might incorrectly test positive for COVID-19. Are you getting me? Yes or
Yes,
no?
sir.
So
There is a
you can see it's all about
sir.
H naught is true, right? It was given that that person is healthy, right? But they incorrectly test positive for COVID-19. What does this mean? So you are making there is a 5% chance of risk of 5% risk of making this kind of error whenever you are going to perform in real life scenario. Okay, so if your alpha is 1%, okay, let's say 0.01, yeah, 1 minute. If alpha is 1%, if okay, then what is the meaning of this? That is only 1% out of 100 healthy people might incorrectly positive for the COVID-19. Yes or no? Okay, so I can write only one out of 100. I mean the same procedure. Yes or no? So there is 1% of 1% chance of making the type 1 error. Okay, is the idea clear here?
Yes, sir.
Yes.
Okay, yeah,
Yes,
someone
sir.
is saying something. Yeah, please go ahead.
Sir, here means type 1 error basically means that how much possibility of making an uh, error when the
Null
means
hypothesis.
it's a kind of human mistake, we can say.
Yeah, human mistake or some variations in your sample data. It can be anything, right? So you are okay with some error. Okay, you have to take a chance of some error. Okay.
Hmm.
So I'm going to give you some scenario. Let me know. Okay. So what is the suppose I'm saying probability of, okay, rejecting that item, or you can say product which is of good quality. What is this? Alpha or beta or 1 minus beta?
Type 1 error.
Alpha. Alpha.
Alpha.
Alpha, right?
Alpha.
So this is possible, right? You can say suppose alpha is 5%, then you will say 5 out of 100 item. I mean they were of good quality, but by mistake they tested as a, I mean we rejected those items, right? Yes or no? Let me write,
Yes,
and
sir.
suppose I'm saying probability of accepting the product when it is of bad quality. So this is
Beta.
beta, right?
Type 2 error.
Type 2 error. Suppose I'm saying probability of rejecting the product which is of bad quality. What is this? Alpha or beta?
Power.
1
Power.
minus beta.
Power
1
of
minus beta. Very good. Suppose I'm writing another thing. Let's say we are convicting
Sir, can you explain why it become 1 minus beta?
innocent
Sir,
person.
this is the sir, power of the test, no? 1 minus beta.
See, what is the 1 minus beta? Power means what? So if you see, if you focus on the power words, 1 minus beta is nothing but you are rejecting the null hypothesis when HA is true, right? Okay, not so you are, so if you see here we have rejected the product or rejected the item when it is was bad quality, right? Okay, so your null will be product is of good quality, and alternative will be product is of bad quality, right? So this is 1 minus beta. So you have rejected the null hypothesis, you have rejected the product when it is of bad quality. Clear? Yes, no?
Yes.
Yeah. So what is this probability of convicting an innocent person?
Alpha.
1 minus alpha.
Not 1 minus alpha. How? Suppose I'm writing acquitting a guilty person, then
Beta.
1 power.
how power? Power is what?
Oh, sorry, sir.
Okay,
Acquitting means what, sir?
He's saved.
he saved, right?
Okay.
He's
Means
saved.
Okay.
Quitting.
yeah. Now, so the next concept is it's already okay. That is called actually p value. Okay.
Sir, excuse me, sir.
Yes.
So can you repeat that last two probability again? I don't get it, sir.
Okay. What will be your null hypothesis in case of innocent person or guilty person? Person is innocent will be your null hypothesis.
Yes, sir.
Then what you are doing probability of, and what is the alpha?
Alpha would be the condition is true, but it rejects it. So convincing. Ah, okay, sir.
Understood?
Got it, sir. Yes,
Okay.
sir.
Hmm.
Yes, sir. Thank you, sir.
Yeah, just think of it. Okay, so what is the p value? P value is nothing but called the lowest significance level at which we reject h naught. Okay, so it's nothing but lowest significance. You can say least alpha basically. Okay, so I will try to draw a graph. Okay, so maybe that should. Okay, so I think we should quickly cover the concept because we have to discuss the questions as well. Okay, so actually this would be standard bell-shaped curve. Okay, so suppose this is your mu. Okay, so suppose this is the mean. Okay, and I'm saying this is the, let's say, c, critical value. Okay, so this, after this, suppose I'm assuming this is the alpha. Okay, this part is represents alpha. This is 0.05. Okay, then in this case you will reject your h naught. I mean, if your T is I mean test statistics will be greater than c, you will reject your h naught, right?
Yes, sir.
And this is your 1 minus alpha. What is the lowest significance value actually? So suppose I'm saying, suppose there is something called c dash or c transpose or anywhere. Okay, and your test statistics is lie here. Okay, suppose this is t. So this is, in this scenario you will reject again, yes or no?
Yes, sir.
So this is the p value. Okay, this whole part is called p value. So what is the p value? So you can say this is, here alpha was what, c, right? But after c dash you are getting the lowest significance level, yes or no? Okay, so
Yes.
situation is, if t is greater than c, then usually I will reject h naught, right? At alpha, correct or not? Suppose after c dash this is alpha dash. So this alpha dash is nothing but lowest significance level. Okay, so if t is greater than c dash, then also I will reject h naught at lowest significance alpha, which is called alpha dash. Okay, yes or no? Okay, so this is just a p value. This will give you the lowest significance level. Okay, so we'll solve some questions related to this. Maybe that will give you the idea. Okay, so I will explain you the general methodology of testing, hypothesis testing. Okay, so I mean, what is the key procedures? Okay, in hypothesis testing. So first of all, let's say you are saying x1, x2, this x and this is our IID x, some distribution x. Okay, so make sure whenever you are going to make hypothesis, null hypothesis or alternative hypothesis, though all those things is all about population parameters. Okay, because you are making the claim in general for the distribution part based on the sample you will test. Okay, then what is the case? So suppose you have to define a test statistic. Okay, so this test statistic usually we are denoting with t. And what is this test statistic t? So this t is nothing but function of the samples. Okay, so Usually you have seen already, so this is x bar or a sample, sample variance and all. So because this test statistic is what, this is the function of samples. Now what will be your test? Okay, after that you will define your test. So test, you will define like, you will reject h naught when, if suppose your value of test statistic is greater than some critical value. So this is right tail test, right? Yes or no? And there is another scenario, you will reject h naught if your test statistics is less than some value, which is called left test tail test. And there is a third scenario, you will reject your h naught if absolute value of t is greater than c. This is called two tail test. Okay, two-sided test. So what is the meaning of this? This means your t value of test statistic is greater than c, or this is less than minus c. It can be anything. Okay, now there okay, so there may be situations of when you are interested to test the mean, right? So mean, like I took one example, mean weighted 100 gram. Okay, then how will you proceed actually? So I will take one example for this mean, and then we'll start the procedure. Okay, so if your claim is about testing the mean, okay, so test for mean, and suppose you have single sample, so what will be your null hypothesis? You will say your mu is equal to some particular value of mu naught. Yes or no? You can see this mu is all about population parameter. Okay, you are making a claim about population parameter, and then based on the sample you will define your test statistics, and then you will proceed for your I mean, whether at the end you will decide whether it's greater than some c or less than some c, then you will decide whether it's reject, you have to reject or accept. Okay, so tell me, what will be your test here? What can be your test here? If see, you can see you're talking about mean. So I will reject h not when, if
X is greater than
t is greater than c.
yes.
And what is the t here? Since we are talking about mean, so
Right till Z
usually,
test.
usually we are saying x bar is greater than c. Okay, so what you will do, this is the claim about population parameter. You will, based on the sample, you will test for this, and at the end you will decide whether, I mean, basically you will find the value of critical value, and then you will see whether x bar, which is given to us, which is that x bar is greater than c, then you will reject, otherwise you will accept it. Okay, so suppose scenario is mu is equal to mu naught, and alternative is mu is less than mu naught, then what will be your test?
X bar is less than C.
You reject h naught if x bar is less than some critical value. Okay, now suppose I'm saying mu is equal to mu naught, and alternative is mu is not equal to mu naught. So this is two-sided. Okay, so what will be your test?
Reject x naught if modulus of x bar is greater than c.
Not x bar, you will say x bar minus mu is greater than c. Okay, so because you will see whether x bar is greater than mu plus c, I mean, and whether x bar is less than mu minus c. Okay,
Okay, sir.
yeah. So what is the usual procedure? I mean, I will write for one, and then we'll proceed. So I will write in general. Okay, then whenever I will solve the problem, maybe that will give you the idea. Okay, so I will write in, I'm going to write in general. So suppose situation is h naught is mu equal to mu naught, and alternative is mu is greater than mu naught. So this is in general steps.
Sir, would you just mind going up once?
Okay.
Yeah, fine, fine. Okay, okay. Thank you.
Okay. So here this is the case. So now tell me again, when you will reject your h naught? If x bar is greater than c. Okay. Now you can see these all situations will be given to you. Okay. No need to worry about this. Like this is the rejection region. This is the no. Okay. These all things will be given to you. Don't worry. Okay, but the steps should be clear. Okay, so how will you proceed? So our task is to compute the value of c. Okay, so we will start with the alpha. Okay, alpha will be given to you. So alpha is level of significance. How will you define? Probability of reject h naught when h naught is true. Now, suppose alpha is given to you 0.05. It can be 0.1, I mean 10%, 1%. Okay. So probability, when you will reject your H naught, tell me, this is the my situation, right? So I will reject my H naught when X bar is greater than C. Given that H naught, what is the H naught? Mu is mu naught. So far, so good.
Yes,
Yes,
sir.
sir.
Right. So what is the next task? So next task is to convert this part into standard normal part. Okay. So maybe you have seen already these kind of concepts. Okay. I will not do the derivation. So x1, x2, xn, if these all things are IID or let's say IID with the with the mean mu and variance sigma squares. Okay. Then what is the distribution of x bar? I suppose this is the normal. This is the normal. Then x bar will follow normal with mean mu and variance sigma square by n.
Yes, sir.
Yes or no? And what is the form? What is the situation to convert to standard normal form? We have to x bar minus expected value of x bar divided by standard deviation of x bar. Right? Usually we have to do this part. Yes or no?
Yes, sir.
This is mu equal to mu naught. I'm writing in general because I will solve some questions related to that it later. So what is the expectation of x bar? Mu naught. Okay, some specific value, and this is sigma by root n greater than c minus mu naught divided by sigma by root n. Okay, so we have substituted the value of mu naught actually. Now, so this part, if you see this quantity will be
Standard
z greater than c minus mu naught divided by sigma by root n. Okay, since this is we have been given the abjad values, to convert in abjad form, what we have to do, we have to convert into less than or equal to form. So this will be 0.05 will be, I can write 1 minus probability z less or equal to c minus mu naught divided by sigma by root n. Would you agree with me?
Yes, sir.
So this will be 0.05 equal to 1 minus fg of c minus this will be c minus mu naught divided by sigma by root n. Right? From here, what else I can say? So fz of c minus mu naught divided by sigma by root n will be 1 minus 0.05. That is nothing but 0.95. So from here, what else you can get? C minus mu naught divided by sigma by root n equal to fg inverse of 0.95.
Yes.
Yes or no?
Yes.
So this value will be given to you. Okay. So
Sir.
basically, and what will be
1.64.
the value of c here? So c minus mu naught, I can write sigma by root n fg inverse of 0.95, and value of c will be mu naught plus sigma by root n fg inverse of 0.95. So this is the value of c you will get from here, and x bar will be given to you. At the end, you have to compare. If x bar is greater than this value c, whatever the value you will have calculated there, then you will reject your h naught, or else you will accept the null hypothesis. Okay, is this clear?
Yes,
Sir,
sir.
here T is x bar, right, sir?
Sorry.
Here T is x bar, right, sir?
Correct.
Yes,
T is x bar. Okay. Why I am saying this x bar is greater than only, then you will reject your h naught, because your my alternative is defined like this one, right? My alternative is mu is greater than mu naught, because based on this
Right.
statistics is, yeah, correct, because of the right tail test. Okay, so should I do for left tail test, or is it okay?
The same process, no, sir?
Same process, right? So in the
Okay,
left tail test, you this greater than sign will be less than, that's all. Okay, and
Got
there
it.
will not be any 1 minus this part. It will be abjad of direct part. Okay.
Sir,
Sir,
two-tailed jet test, will you explain?
I will come to that. Okay, don't worry. Let me go
Okay.
step wise. Okay.
Okay.
sir,
Okay.
where that mu equals to mu naught, like in the
I think
previous
you should
example.
focus from the here. See, mu is equal to mu naught here. It's given that null and alternative. So I wrote here in general. So mu is equal to mu naught. It can be in the question. It will be given that, let's say we are talking about mean weight of some product. So let's say it's 100 grams. So mu will be 100. So what you have to do? You have to substitute this mu naught as 100. This is the specific value of mu, which is your
No,
claim.
sir. I was asking in the second step, like
Where?
Yeah, this one, sir.
This one.
After that, yeah, after
What is the
that,
issue? What is
after
the
that
expected?
step, yeah,
What
after
is
that step,
what is the distribution of x bar here?
normal.
Normal is what? Mu comma sigma square by n.
Yes,
So
sir.
what is the expectation of x bar? Mu only,
Yes, sir.
right? And what is the value of mu?
Mu naught. Okay,
That's
we are
all.
substituting that. Okay.
Okay.
Yes, sir.
Now, so this was the scenario test for mean. So this is test for mean when sigma square is known. Okay. I mean sigma square is was given to us. It will be given to us. What if sigma square is unknown to us? Okay. Then in that scenario, if sigma square, I mean this is the test for mean. Okay. When sigma square is unknown. Okay. So if sigma square is unknown to you, then in that scenario, we will go for the t test. Okay. So situation is x1, x2, so on, xn. This is, let's say, this all are IID normal with mean comma sigma square. Your samples will be from normal distribution, and this is sigma square is unknown to us. This is not known. So this is the case. I will go for the t test. What is the test t statistics? So this is x bar minus mu s by root n will follow t n minus 1, right? While in case of z test, okay, what is the difference in case of z test? So z test x bar minus mu divided by sigma by root n. This is follow normal 0 comma 1, right? When this is true, when sigma is known to us. If sigma is unknown to us, so x bar minus mu, so this sigma, instead of this sigma, I will use the sample standard deviation. So this will follow t n minus 1. Okay. So this is when sigma square is unknown. So this is called test statistic. Okay. So the same scenario, I mean, you are going to test for mean, but sigma square is unknown to you. Okay. So what is your null hypothesis? So let's say null hypothesis mu is equal to mu naught again, and alternative is defined as mu is greater than some mu naught. Okay.
Excuse me, sir.
Hmm?
PDF will be provided, na, sir?
Yes.
In supplementary content, sir?
Not supplement along with the question paper. There is no supplementary content in question paper. Okay. So you will reject your H naught if T is greater than C, or since we are going to test for mean, so I will say this is X bar greater than some C. Okay. Now, so how we should proceed? As usual, alpha, right? Alpha is probability of rejecting H naught when H naught is true. Everyone is getting right these procedures and all.
Yes, sir.
So alpha is probability of T is greater than some C, greater than, given that mu is equal to mu naught. And what is the usual process? What I have to do? This is x bar minus C, given that mu is equal to mu naught. Okay. Now what I will do? I have to convert into standard normal form. And for that, what I have to do? I will subtract the mean and I will divide by the standard deviation. So what is the standard deviation here? S by root n. You can focus because sigma square is unknown to us, right? Greater than C minus mu divided by S by root n, given that mu is equal to a specific value which is mu naught. Okay, so tell me what should I write here? Z or something else?
T n minus 1.
T n minus 1, right? Because this is going to follow T distribution with n minus 1 degree of freedom. So we are not going to this much depth because you can find from the lectures. Okay. So since we have to revise only, so this is C minus mu naught divided by S by root n. So what we have to do? We have to convert into 1 minus P just less than or equal to form to get the, CDF form, right? So what it will be? It will be alpha is equal to 1 minus, this is, I can write F T n minus 1. Yes or no?
Yes, sir.
Okay. And from here, what you will get? So F T n minus 1 C minus mu naught divided by sigma by root n is equal to nothing but 1 minus alpha. And from here, it will be C minus mu naught divided by sigma by root n is equal to nothing but F T n minus 1 inverse 1 minus alpha. So at the end, you can substitute the value of alpha. Yes?
S by root n, right?
Yeah, sorry. Yeah, it's S by root n. Thank you for the correcting me. It's S by root n. Sorry about the mistake. So from here, what will be the value of C? So this will be S by root n into f t n minus 1 inverse 1 minus alpha, and value of c will be mu naught plus s by root n f t n minus 1 inverse 1 minus alpha. So this is value, you will get some value of c, and at the end what you will do, whether basically you will compare whether x bar is greater than c, you will reject, otherwise you are going to accept. Is this clear?
Yes, sir.
Yes.
Yes.
Okay.
Sir,
So
formula will be given in the sheet, sir.
sorry,
Formulas will be given in the
I think yes,
exam.
yes, it will be given. It will be given. Okay.
Okay, sir. Thank you, sir.
So you can see these are the test for mean. Okay. So in the formula sheet, you can say this is for single. If you will talk about two-sided test. Okay. Okay, two-sided. So I took just I discussed for here, right? Just for greater than, less than. Similarly, you can do, and similarly you can do for two-sided test also. Yes or no? So what
Yes,
will
sir.
be the thing is, so this part will be replaced by okay. Let me explain you.
सर
So
मीन माइनस
basically,
प्रायर मीन हो जाएगा सिर्फ उसकी जगह, हाँ?
see this z part. So this x bar is greater than c. If you have two tail tests, then this x bar will be greater than c will be replaced by x bar minus mu greater than c. Are you getting? And given that mu is equal to mu naught. Is this okay?
Yes.
Yes, sir.
So I mean, basically, I mean the usual steps you have to follow. I mean, for two tail test actually. Let me just make a box here. Use some other color. So actually, for two-sided test. So what will be alpha is nothing but probability of then x bar minus mu is greater than c, given that mu is equal to mu naught. Okay. Yes. Do you any query? So this is okay. So how will you proceed here? Probability that alpha is equal to, then you will write uh, x bar minus mu can be greater than c, or x bar minus
Yes.
mu can be less than minus c, given that mu is equal to mu naught, right? And this will be alpha, then this will be x bar is greater than mu plus c, or x bar is less than mu minus c, given that mu is equal to mu naught. Would you agree with me?
Yes.
So what it will be? Probability that x bar is greater than mu plus c, given that mu is equal to mu naught, plus probability x bar is less than mu minus c, given that mu is equal to mu naught. And then at again you have to convert in standard normal form or something like that. So this, okay, you can do it here, or else you can do directly here. Okay. So what I mean by directly, so this is alpha is equal to probability that x bar minus mu greater than c, given that mu is equal to mu naught, right? Okay. So
Yes.
we know we have to convert in standard normal form, and what for that we have to do. So suppose this is mu comma sigma square n. Okay. So what we have to do, we have to subtract the mean and we have to divide by standard deviation, right? But here if you see, this is already subtracted by
Yes.
mean, right? So what we have to do, we have to just divide by sigma by root n. Yes or no? So this will
Yes, sir.
be greater than c divided by sigma by root n, given that mu is equal to mu naught. If you see, this part will be g greater than c divided by sigma by root n. Yes or no?
Yes, sir.
Yes,
And
sir.
this will be again g greater than c by sigma by root n, or z less than minus c by sigma by root n. Okay. I mean, you can do in this way also. Okay. So just so just start with the alpha and convert into the standard normal form. Is this clear?
Yes, sir.
Okay. Okay, great. Now the thing is, so far we discussed about, you know, when you are interested to test for mean. What if you want to test for the variance? So there is called chi-square test for variance. Okay. So the test for the mean, we have seen z test and t test, right? But for variance, there is something called chi-square. So what are the test statistics actually? So test statistic defined is nothing but so n minus 1 times capital S square divided by sigma square will follow chi-square with n minus 1 degree of freedom. Okay, this is uh, This is called test statistics for chi-square, and what where s square is nothing but 1 upon n minus 1. This is sample variance actually, xi minus
Yes.
x bar whole square. Okay, so I will proceed with the steps basically. So in general, suppose x1, x2, xn, okay, these all are from IID normal. These are normal samples in case of T statistics also. What was the difference? Sigma square is unknown. Here we are interested to test for variability, right? I mean, you can be interested, right? Rather than just for mean, you can interest in the, to check the whether variability is greater than this or less than this or not. Yes or no? So what will be your null hypothesis? Sigma is, let's say, sigma naught, and alternative is, let's say, sigma is greater than sigma naught. You can define sigma square equal to sigma naught square, or sigma square greater than sigma naught square. That's not a problem. So what will be your test? Tell me. So in case of mean, we decided I will reject H naught if X bar was greater than C, right? I mean, our
Yes.
null hypothesis was about if mu is equal to mu naught and alternative mu is greater than mu naught, then we saw I will reject H naught when X bar is greater than some C. What will be your test statistics here? If
X
Variance.
S square
sample
is
variance
greater
is
Greater
greater than
than
some C,
C.
or sample standard deviation is some critical value? Yes or no? Yes or no? Is this clear?
Yes.
Are you able to so this is the test statistic. Now how to proceed? Usual procedures we have to follow. So what will be your first step? I will start with the alpha, because alpha will be given to me. So this is probability of reject H naught, given that H naught is true. So when you are rejecting your H naught, when S is greater than some C, and what is the H naught? Sigma is equal to sigma naught. Okay. If you see, if you focus carefully, what is the chi-square test statistics? It involves n minus 1. S square divided by sigma square will follow chi-square n minus 1, right? So I need S square. So what should I do? Can I do S square greater than C square? Yes or no?
Yes, sir.
To convert in chi-square test statistics, what I have to do? I have to multiply with n minus 1 on both sides. Yes or no?
Yes.
Then I have to
Yes.
divide with the sigma square. And what is the specific value of sigma? Is sigma naught. So I will substitute this value. Clear?
Yes.
Yes,
So
sir.
what is this part now?
Chi-square.
chi-square and
Chi
This will
square
be
n minus 1.
chi-square n minus 1 greater than n minus 1 c square divided by sigma naught square. This sigma naught square will be, you can find from your null hypothesis, right? Now to convert into abject form, not abject, I mean in the CDF form, I can write as a 1 minus probability chi square n minus 1 less or equal to n minus 1 c square divided by sigma naught square. Would you agree with me? So from here, can I write P alpha equal to 1 minus f of capital F of chi square with n minus 1, n minus 1 times c square divided by sigma naught square? Yes or no?
Yes, sir.
So from here, what would I get? F chi square n minus 1, n minus 1 times c square divided by sigma naught square equal to 1 minus alpha. Yes or no? So from here,
Yes, sir.
I would write n minus 1 c square divided by sigma naught square equal to f inverse 1 minus alpha of what? Chi square n minus 1. So this, the subscript itself, I'm writing f chi square. So this is a CDF for that. Okay. What will be the value of c square here? So c square will be sigma naught square divided by n minus 1 into f of and inverse of 1 minus alpha chi square n minus 1. So from here you will get the value of c square, right? And what is your test? According to your test statistics, if the value of sample variance is given greater than c square, then you will reject your null hypothesis. Otherwise, you will accept your null hypothesis. Is this clear?
Yes.
Yes, sir.
Okay. Okay. So far, you got the rough idea about this kind of test and all.
yes, sir.
Okay.
Yes, sir.
Okay. Then let's do for two sample test, and then we will see the questions. Okay. So usual procedure we have to follow in case of two sample test also. So like see in single sample test you can make a claim mean weight is 100 gram and or something like that, right? But there is also possibility. Suppose there are two kind of let's say two you have two different samples. Okay, I mean basically you want to check for two different samples whether let's say mean weight of this product, let's say mean weight of product A is equal to mean weight of product B or not. Okay, suppose your claim is you are saying mean product of product A is same as the mean product of mean weight of product B. I mean you are saying both product are equally effective. Okay, but alternative can be whether mu of A is not equal to mu of B, or mu of A can be greater than mu of B, or mu of A can be less than or mu of B. Are you getting? The same three kind of situations can happen in case of alternative hypothesis also. Okay, the same thing which we saw in case of single sample test. Okay, is this clear? Okay, the situation is let me write situation. So I'm saying two sample jet test for me. Okay, two sample jet test for me. So when you will use this jet test, when sigma square is known,
Known.
right? If sigma square is unknown, I will go for t test. Okay, situation is x1, let's say x1 x2 so on till xn1. Okay, this is IID sorry, this is IID normally distributed, let's say with the mean, no, mu1 comma sigma 1 square. And there is another sample which is y1, y2, so on, yn 2. So this n1 and 2 represent the size of the sample. This is IID normal mu2 comma sigma 2 square. Another thing is these two samples would be independent. Okay. Now tell me, what will be the distribution of x bar normal with mean
Mu sigma square.
mu1 and variance sigma 1
Sigma
square divided by n1,
Yes, sir.
Yes.
and y bar
Mu 2 comma sigma
sigma 2 square divided by n2, right? Yes or no?
Yes, sir.
So what will the distribution of x bar minus y bar, because we are interested in two sample test. Okay, so you want to check. Okay, so this is normal. If you subtract this mean, so expected value of x bar minus expected value of y bar, this will be mu1 minus mu2. And what will the variance? Sigma 1 square divided by n1 minus sigma 2 square divided by n2. Yes or no?
Plus.
Yes.
Plus. Yeah, that's what I wanted to check. Okay, it's not minus here. Okay, that will be plus. You can cross check. Okay, one more thing. If this is the case, how will you proceed basically? Okay, so the situation is, what will be your test statistics? So you can say this x bar minus y bar, or what will be y bar minus x bar normal mu2 comma mu2 minus mu1, and variance will be same anyway, it will be added, right? Yes or no? Are you getting my point?
Yes.
Okay, the situation is, suppose your no, your null hypothesis, you are saying both, suppose there are two kind of machine. Okay, and machine A and machine B, I mean machine 1 or machine 2, and you want to check whether machine A is equally effective as compared to machine B or not. So what you will say, average performance of machine A is same as average performance of machine B, right? And what can be your alternative? These two are not same, or it can be changed. I mean you can say machine 1 is more effective than machine 2, or machine 2 is more than effective machine 1. Accordingly you can decide, right? That depends on the situation. So what will be your test statistic? Usually we are taking t as a y bar minus x bar. You can take x bar minus y bar, but usually it's y bar minus x bar. That's not a problem at all. It's not a problem. Okay, because we have to take absolute value. I will tell you. So this is sigma 1 square divided by n1 plus sigma 2 square by n2. So you can go with y bar minus x bar. It won't affect actually. So what will be your test? So test is nothing but I will reject my h0 if, so what should I write? Absolute value of t is greater than some critical value. Yes or no? Because this is two-sided. Yes or no?
Yes.
What will be usual procedure? What is the alpha a probability of rejecting H naught given that H naught is true. And how will you write here? Absolute value of T is greater than some C. And what is the H naught? H naught you will write mu1 is equal to mu2, right?
Yes.
So as usually we have to proceed actually. So what is this? Y bar minus X bar greater than C, and given that mu1 is equal to mu2. Tell me, if distribution of Y bar minus X bar is normal, no, mu2 minus mu1 comma sigma 1 square divided by n1 plus sigma 2 square divided by n2. Tell me, under H naught, what I mean by under H naught, I'm saying mu1 is equal to mu2. So if you see, so Y bar minus X bar will follow normal 0 comma, yes or no, this variance.
Yes.
Why under H naught? Because under H naught you can
mu1
see
equals to
mu1 minus mu2 both will be
Zero.
0, right?
yes.
So what you have to do, you have to, there is no need to subtract 0. You can directly divide by the square root of this part. Are you getting my point? Yes or no?
Yes.
To whenever you want to convert in standard normal form in Z form, what you will do, usually we are dividing, okay, usually we are subtracting mean of this part Y bar minus X bar, we are dividing by the standard deviation of square root, I mean divide by standard deviation, right? Here under H naught, basically when mu1 is equal to mu2, you will, there is no need to subtract, because you will subtract 0 anyway, you get this. You have to, what you have to do, this will be C divided by square root of this sigma 1 square divided by n1 plus sigma 2 square divided by n2. Yes or no? Would you agree with me?
Yes.
Yes, sir.
Okay, correct. Now, so there is a last thing called, two sample F test for variance. So before going to that, actually, what is the F test? F test is nothing but it's a ratio of 2 chi square divided by respective degree of freedom. Okay, let's not go in that much depth. I will quickly go through the.
Excuse me, sir.
Hmm.
Can you conclude again the above one?
One second. Two sample F test for variances. Yeah, sorry. Yeah.
Can you conclude this last part, sir? I've understood 0 comma sigma 1 square by n1.
So what
After
I
that,
mean, okay, after this, see what is the usual process what you will follow. I'm not writing because the same thing. We have to convert in standard normal, right? Because this is Z test. To convert in standard normal, what you have to do, we have to subtract the mean. So you will subtract the 0. So it will be C minus 0 and divide by this quantity, square root of this quantity, right?
yes, sir.
That's all.
Okay.
Okay.
Yes.
So, but the thing is, what you have to take care if when for deciding your whether you are going to reject or accept null. So this is the case. You will then you have to subtract y bar minus x bar. This would be greater than some c. Okay, you have to, usually for single sample test we are just checking x bar is greater than c, but here you have to test this part. Okay. Now what is the two? Okay, when you are interested in two variances to check the variability of two parts.
Sir, actually your voice is low.
See, this mean part is okay. When you are interested, when will you be interested to check the variability of two samples?
When they are from different distributions.
No, I want real life some situation. Can you think a bit? See, for mean, you can say mean weight of machine A is equal to mean weight of machine B. What about variance? Why we are interested in variability? Anyone? See, if you understood the this part, mean
Sir,
part,
if
I think you should give me the idea of this part, right? Just
sir,
think a minute. Yeah.
sir, if like if a company is manufacturing, say for example, uh, two different screws, or bolts and nuts, they are of different specifications. So say for example, there is one bolt type B1 and another is bolt B2. So basically the variation I don't know if I'm right or wrong, if I'm going right or
Oh,
wrong.
go ahead, go. No worries. It's not
Yeah.
about any exam
Yeah.
and all.
So,
Go ahead,
so,
whatever.
so basically, this is used when, say for example, there is a variation in size. They are using the same manufacturing process. There
Hmm.
is a variation in size of the bolt B1 and there is a variation in size of the bolt B2. So basically, when they are comparing both the variations, I think that is the time when this test
Correct,
is.
correct. Variability you want to change. You are not
Yes,
in
yes.
me. Okay, let me give some two different situations. Suppose there is a researcher or an analyst. He wants to compare the consistency of a student, marks of the student in two different school. Okay, so you can see here what. How will you check your consistency? The one, okay, suppose there are, okay, let me, before going to school, let me give you the situation of two students. Suppose there is student A and student B. Okay, and he scores, let's say, in five subjects marks like this: 90 and 98, 97 and 99. And student B scored marks like this: 90, no, 19, 58 and 72 and 32. Which student is more consistent?
Student A.
Why?
Student A.
Because there is less variability,
There's
Yes.
variation.
less variation in the marks, right? And student B is not more consistent, right? Similarly, if you want to check the consistency of school A and school B, right? And then there are some, let's say this is the marks of five different students. Okay, then you will say school A is more consistent. Students of the school A is more consistent,
Yes.
and something like that. So what will your null hypothesis? Your null hypothesis will be variance in, I'm writing school A is same as variance in school B. Yes or no? And what
Yes.
will be your alternative? Let's say variance in school
School A.
A is, let's say, not equal to, okay, and variance
Yes.
in school B. Is this clear? Some rough idea?
Yes, sir.
Similarly, you can say the for manufacturing company. Suppose there are two machines, they are filling the soda bottles, okay, and they
Yes.
want to test whether is there a variability in the volume filled by machine one or machine two. What will be your alternative? Variance in machine one is same as variability in machine two, but alternative will be
Not equal.
not equal to. Is the rough idea clear?
Yes.
Yes, sir.
Okay, great. So
Sir,
these kind of situations where this you to use for this app test for two sample variations. Okay. Hmm.
sir, would you just mind going to, sorry, in the above slide, yeah.
Hmm.
In this two sample Z test,
Hmm.
sir, say for example, it's a right tail or it's a left tail test.
Hmm.
Uh, in that case, sir, we will concentrate on is the mod, will the mod be needed in this case? Just wanted to ask. If it's a
Mod? No, I don't think. I think mod. I don't think it should be needed because see, mod is no. In that case, it's not. It's just about if not equal to, then you have to consider the mod, because not equal to means you are. It can be greater than or it can be less than, right?
right,
Usual
right.
part is whether t is greater than less than or, okay, so don't
Okay.
worry about those kind of scenario. As usually we are just going with this part. Okay, what are
Okay.
the situations is given to you, we are going to consider this part. Okay, don't worry about
Okay. Okay.
that. Okay,
So
but
thank you.
anyway, it's a key thing is, so whatever the test is statistic, right tail it will be greater than, left tail less than, or two tail is not equal. Oh,
Not
sorry,
no,
mod
sorry.
of t is greater
Not
than
too
c. Okay,
good.
so this
Okay.
t can be anything, whether it's x bar, y bar minus x bar, doesn't matter. Okay.
Okay. Okay. Sure.
Okay.
Thank you.
So what is the app test part? I will quickly cover.
So here we can say like that if we want to choose from multiple source, then we go with two test.
Multiple source. What do you mean by multiple source?
Multiple source means here suppose sample A, sample B,
Hmm.
doing the same work.
Doing the?
Doing the same work.
Huh?
Then we want to choose from both of one.
No, actually, sorry, I didn't get your question. Can you?
I think, sir, he is asking for test statistics type or test means the null and alternative hypothesis के लिए वो पूछ रहे हैं शायद ऐसा कुछ.
Oh, let him complete. Yes, can you please come again?
No, actually I am saying suppose I have a one work A. For performing this work A,
Hmm.
2 or 3 type of person is there.
Hmm.
Then we go with this type of test.
Correct, correct. Only then variability will be there, right?
Okay.
Okay. So for two sample test, we have this F test and all. If you want to move more than two sample test, that's those kind of things will come in degree level part. Okay, that's not a problem. Okay. As of now, we can focus on this. Okay, that you are correct. So like here, I told you, right? Here we are going to check the marks of in two school, right? School A and school B. It can be school C also. Okay, then you have to do for variability in school B and C. You can compare A and C, something like that, as per your objective. Okay.
Yes. Yes, sir.
Okay. So what will be your null hypothesis? Actually, you will say variability is same and alternative is, so let's say I'm saying sigma 1 square is greater than sigma 2 square for one sample. Okay. So what is the T statistics actually? So T statistics is nothing but called this S1 square divided by sigma square divided by sigma S2 square divided by sigma 2 square. This follows F statistics n1 minus 1 comma n2 minus 1. Okay, this is for first sample, this is for second sample. Okay, so one more thing actually, under H naught, if you see under H naught, so when you will apply your null hypothesis, so under H naught, sigma 1 is equal to sigma 2. Okay, if this is the true, then this S1 square divided by sigma 1 square divided by S2 square divided by, again this will be sigma square, this will get cancelled out. So at the end, what you will get, S1 square divided by S2 square will follow F statistics or not? Yes or no?
Yes.
This will follow F n1 minus 1. So this is not C depth. This is F statistics, comma n2 minus 1. Actually, we are not going into the too much depth from where this S1 square divided by S2 square is coming. Actually, this F statistics is nothing but, so there is suppose 2 chi-square test. Test statistics. So if you want to take the ratio of these two and if you have to divide by corresponding degree of freedom, this will give you the F statistics. Okay, so from there it will come, but anyway, that's not a that's not matter here. Okay, we can discuss later if the time allows. Okay, so the thing is, we have to start with as usual. Here we are taking the ratio of S1 and S2 square. Can you tell me what will be the maximum value of this S1 square and S2 square? What can be the maximum value of? When you will reject? Tell me, see, under H naught, it can be max to max 1 only, right?
Greater than 1.
Greater than
No,
1.
no, under H naught.
Okay, under H naught.
Maximum will be 1, right?
Maximum is 1, yes.
Yes.
Because sigma square, if sigma 1 square is equal to sigma 2 square. Suppose there is something called right side, some variations to the right side and some left side. Suppose this is CL. Okay. CL means critical value to the left, critical values to the right. So this quantity is 1 plus CR, this quantity is 1 minus CL. So when I'm going to reject H naught, so if my test statistic is less than this part, 1 minus CL, and my test statistic is greater than 1 plus CR, I will reject H naught. Because see, why this one? Because this will be approximately 1 if null hypothesis is true, right? That's what we are doing, right? Alpha, we are proceeding, yes or no? So I'm going to reject H naught if this test statistics is greater than 1 plus CL and test statistics is, what I mean say, I will reject H naught if T is greater than 1 plus CR or T is less than 1 minus CL. Okay. So why this is part actually, in F statistic, what is the graph of F statistic? If you see, this is not symmetric actually. The graph of F statistic is something like this. Okay, this is bad, but this is not symmetric. So suppose this is 1 is somewhat here. Okay, so and then this will be 1 plus CR and this guy will be 1 minus CL. Okay, so suppose this is the, okay, what it will be? I can write alpha by 2. Yes or no? And this blue part again alpha by 2. Okay, so this alpha by 2 is what? Probability of rejecting H naught. So T will be greater than 1 plus CR given that H naught and probability that T is less than 1 minus CL given that h naught. Okay, is the rough idea clear?
Yes.
Okay. So okay, as of now, actually we have covered all the concept in theoretical way. Is this clear to all of you? I mean, the key idea you got, how to solve the questions in general and all. Okay, okay, I can see some thumbs up. So I'm hoping you got some idea. Okay, then I have collected some questions. Let's try to solve those questions, whatever the concepts we have learned so far. Okay, now let's do this question. Okay. So this question is saying, suppose the moment generating function of random variable x is given to you this, you have to find the value of p, which is lies, I mean, probability that -4 less than x less than 4 in terms of fz, where fz is CDF of a standard normal variable. If you see here, if you focus here, so this is what? This MGF is what? Can you recall something? If x follows normal 0 comma sigma square, then what is the MGF of this part? E raised power lambda square sigma square by 2. Yes or no? Because we have to convert in FZ. To convert in FZ form, this x to convert in this x into Z form, we need to subtract the mean and we need to divide by the standard deviation. Yes or no? But here
Yes.
we don't have any information about mean and variance. That means we have to, there is something another trick. So we know if x follows normal 0 comma sigma square, then mx lambda is e raised power lambda square sigma square by 2. Okay. So by using this, can I write here e raised power? Tell me what should I write? Can I write 4 times sigma square divided by 2? This not sigma square, 4 times lambda square. Are you getting? Can I write? It's 2 lambda square. Can I write 4 times of lambda square divided by 2? Would you agree with me or not?
Yes, sir.
Yes or no?
Yes.
Yes, sir.
So what is the value of sigma square here?
4.
Okay, this means sigma square is 4 and mean is 0 only.
So whether this formula will be given or we should just
No, so this
by
is
heart
something I
ourselves.
think this is something you have to buy heart. This normal, this not for only for normal. I'm not saying for other distribution. Okay.
Okay, sir.
Okay.
So
So
if that mu is available, what's the formula, sir? Lambda square sigma square by 2 plus mu into.
actually, it's in general, it's mu lambda. This is the part. Okay.
Okay, sir. Thank you, sir.
Now, so what we got mean as a mu as a 0 and sigma square as 4. So what we have to do? We have probability that -4 less than x less than 4. So what is the what should be our next step? Okay, our next step is we have to subtract the mean and divide by the standard deviation, which is 2. So x minus 0 divided by 2 less this is 4 minus 0 divide by 2. Would you agree with me?
Yes.
This will be probability that -2 less than z less than 2. Yes or no? So
Excuse
we,
me, sir.
yes.
Can you tell that above part again? Like 4 lambda square by 2.
So this part we have given, right? E raised power 2 lambda square. Okay. If you
Yes.
want to relate with this, can I write 2 lambda square as a 4 lambda square by 2? Yes or no? Okay.
Yeah.
This part we know probability a less than x less than b. I can write f of b minus f of a, right? So this part I can write f z of 2 minus f z of -2. Would you agree with me?
Yes, sir.
Okay. And what is this f z of 2? Okay. What is the, you can say usually it's a c, right?
Matches with option C.
Option C is correct. Yes or no? You can see. No.
Excuse me, sir.
Hmm?
That first statement came, na, sir. That thing can you tell again?
Sorry?
The first statement, sir. Can you scroll up?
Huh?
That e power 4 n square by 2, that thing. From this form to this form, how it was generated, sir? What is this? A standard formula?
This is standard formula, yeah. This is something
For
you have to
normal.
recall from lecture, okay? And this is given to you. We have to relate with this. So I can write 2 lambda square as a 4 times of lambda square by 2. Okay. Okay, so the next question is, consider 100 samples x1, x2, x100 IID normal mu comma 36. Let the null and alternative hypothesis is mu equal to 4. And see, you can see null is given to as this and alternative is, here we have given a specific value which is mu equal to not minus 4. There is a test statistic which is mean, sample mean only, x1 plus x2 plus so on x100 divided by 100. You can say this is the function of samples. Consider a test which rejects the null hypothesis if t is less than c for some constant c. Question is, what is the level of significance in terms of c? Okay. So what is the level of significance? So first of all, what is the alpha? Alpha is level of significance only, right? So alpha is what? Probability that I will reject H naught when H naught is true. So what is the, when you will reject your H naught? Tell me, when t is less than c and H naught is what? Mu is equal to 4. So far so good. Now, what is the next task? Next task is to convert into, and what is this t? T is nothing but here x bar is only, right? You can see.
Yes, sir.
If you see, what will the distribution of x bar? X bar will follow normal mu comma 36 divided by 100.
100.
Right? Very good. So this alpha will be probability. And next task is, if x bar follow normal 36 comma, sorry,
Mu 36 divided by
mu comma 36 by 100. So you can see in from the question itself, our samples, we have drawn my samples from normal distribution with mean mu and 36. Here sigma square is given to us, right? If sigma square is unknown to us, then this will be t, right? T and minus 1, right? Not z. Got the difference? Everyone is getting the difference or not?
Yes, sir.
Right?
Yes, sir.
Okay. So what is the next task? I have to subtract the mean. So I will do x bar minus mu divide by 6 by 10, right? Less than, because sigma by root 10, right?
Yes,
And
sir.
sigma square. So this will be c minus mu divided by 6 by 10, given that mu is equal to 4. Now, first of all, this alpha is probability that this will be z less than c minus, what is the value of mu? This is 4 divided by 6.
4.
Okay, 6 by 10 will be 3 by 5. So this will be probability that z less than 5 by 3 c minus 4. Yes or no? So this alpha will be
Yes, sir.
fz of 5 by 3 c minus 4. Is this clear?
Yes, sir.
Okay.
Yes, sir.
So
Yes, sir.
at the last, what we can do, alpha equal to fz of 5c minus 20 divided by 3. Okay, so you can see this option D is correct. Okay, so can you tell me when this option will be correct? This option number 2.
When
When
you
it is less
Lifting.
T greater than
Correct. That's very good. Means you are getting the concept. So you can see this is usual procedure, right? Alpha, you have to identify, reject, and then
Yes.
okay. Okay, let's try to solve some other question. Okay, so next question is, I mean, the similar way, but the I mean, sample size and this variance, you can see variance is 16 here. Initially it was 36. But here question is, you have to find the power of the test. Okay. So what is the power of the
Means, sir, one minus
1
beta.
minus
1
beta.
minus beta.
Correct. So 1 minus beta is what? Probability that, tell me.
It's reject.
Rejecting given
Rejecting
that
H naught when
H not
H
when
is true.
H is
H
true.
H is true, right? So you can see in this case, value of H is given to us. So mu we have to take minus 1. See, do not take mu is equal to 1 here, because I'm talking about HA, right?
Yes,
Okay,
sir.
so be careful. So when you have to reject the null hypothesis, when T is less than C, given that mu is equal to minus 1.
Minus
If you will
1.
take mu is equal to 1, right? So you will get option D as a correct. But you have to take mu is equal to minus 1, because in case of power, HA is true. If this is alpha, then you have to take mu is equal to 1. Is the difference clear?
Yes, sir.
So what is the distribution of x bar here? You can see I have to convert in fz, because variance is known and we have to hypothesis about. So what is the distribution of x bar? This is normal mu comma 16 by 100.
Yes.
Okay, so I will quickly go through the steps because we have to solve some more questions. So this will be x bar less than c, given that mu is equal to -1, and 1 minus beta will be probability that x bar minus mu divided by 4 by 10 less than c minus mu divided by 4 by 10, given that mu is equal to -1. So this will be z less than, what is the value of mu as a -1? So c minus of -1 divided by, it will be 2 by 5. So this will be probability z less than, sorry, z less
5
than
times x.
c plus 1 divided by 2 by 5. So probability z less than
5c
5c
plus 1.
plus 2 divided by 5c plus 5, right?
Yes, sir.
Yes, sir. 5.
Okay, so this is 1 minus beta. So in terms of fz, it will be fz of 5c
5c
plus
plus
5
1
divided by.
divided by 2.
Is this clear?
Yes, sir.
Okay.
Yes, sir.
Okay, so the next question is again power of the test, but here you can see our test has been changed, right?
Lefty
Okay,
test.
so
Yes.
will you be able to do for this, right? Just we have to subtract the
Yes,
mean
sir.
and all, right? I'm skipping this question. Okay.
So it's quite a right-tailed digit test, no?
Yeah, it's the right there. Okay, let's focus this kind of questions. So this kind of questions important actually, okay, for your exam. So tell me, do not just see this option B and tell me the correct answer. So situation is, university claims that average time for students to complete a particular exam is 60 minutes with a standard deviation of 5 minutes. Okay, so here you can see sigma, this is sigma, right? This is mu, okay? Sigma is, that means you have to use the J test here. An analyst believes that the average time is less than 60 minutes. He randomly selects 100 completed exams and finds that average completion time is 59.3. So what is this 59.3? This is
HA.
X bar.
Sorry.
Yes or no? Because this 59.3 is coming from when he collected the sample for 100, right?
Yes.
What is the null and alternative?
So null
Mu
is
is equal to 60
X bar equal to 60.
and
X bar
yeah,
does not increase.
B option.
B option. Okay. Anyone can tell me the reason why not option C? What is the wrong with option C?
So basically, in the option C is not correct because the mu has been given as 60 and not the sample mean. Population mean is 60.
Correct. Also, whenever you are going to make the claim or hypothesis, it's always about population parameter. Okay, for there will be claim for your population. You to based on the sample, you will test that claim, right? So this is true. Okay, this is the left tail test. When you will reject your H naught, tell me what will be your test? I will reject my H naught if, tell me when.
When X bar is less than C.
X bar is less than C. X bar is less than C. Yes or no? Because
Yes,
this
sir.
is left test. One more thing. So this X bar is given to us 59.3. What you have to do? You have to calculate the value of C and you have to check whether X bar is less than or not. Okay. So let's proceed. Okay. So if you see in the question number 2, it is asking for 5% and 1%. Okay. So we'll do quickly. Okay. So let me write. Okay. First of all, what is the distribution of X bar here? X bar will be normal with mean mu. So this is mu comma
60 comma sigma square by n.
that is 25 divided by 100, right? N is 100. Yes or no?
Yeah, 25 by 100, yes.
Okay. And mu is we have defined as a 60. Okay, now, so we have to start with alpha. So alpha is probability of reject H naught when H naught is true. So alpha is given to us. Okay, let's write at general because we have to test for two different values. Okay, I will go in general. So what is the when you will reject your H naught based on this null hypothesis? If your X bar is less than C. Are you getting my point? So if you see, we have to do X bar minus mu divided by 5 by 10 less than C minus mu divided by 5 by 10 given that mu is equal to 60. So this will be Z, okay, Z less than C minus 60 divided by 1 by 2. Yes or no?
Yes.
So this will be probability Z less than 2C minus 120. Everyone is getting? Yes, no?
Yes, sir. Yes, sir.
So FZ of
Yes, sir.
2C minus 120, right? So from here we will get 2C minus 120 equal to FZ inverse of alpha, right? So similarly, what will be value of 2C equal to 120 plus FZ inverse of alpha, and value of C will be 1 by 2 times 120 plus FZ inverse of alpha. So now what you have to do basically, so this is in general, so if alpha is equal to 0.05, so C will be half 120 plus FZ inverse of 0.05, and what if I can recall correctly, so FZ inverse of 0.05 is nothing but minus 1.645. You can cross check, don't worry. You too, this value will be given to you. I mean, it will be given like this: FZ of minus 1.645 is nothing but 0.05.
Yes, sir. Yes.
Okay, this will be given to you. Okay, so from here value of C will be, if you can calculate, and all, anyone can calculate and let me know.
Sir, is alpha value is constant like 0.05?
It's not about constant. It will be it will be given to you whether it's a 5% or 1%. Okay.
Okay.
It's coming 58 point something.
58 point. Can you check? I don't think 58.
59.177.
17. Let's say 59.18.
Oh, sir,
Okay.
yes, yes, yes.
Okay. So if this is the case, and in case of alpha 0.01, then my C will be 1 by 2, 120 plus FZ of 0.01. Okay. So FZ of actually minus 2 times 32 is equal to 0.01. So from here, what will be FZ inverse of 0.01?
Minus 2.32.
Minus 2.32. So you can solve this. So value of this will be minus 2.32. So 180, 17 point something. So 117, that is 58 point something.
84.
83. Okay.
58.84.
So, okay, you can see what is the value of X bar is given to us? 59.3, right? In both cases, you can see this C is what here?
Critical value.
Critical value, whether it's greater or less. My question is
Less
that.
Less,
Less,
less.
right? So
C
as
is
per null
lesser.
hypothesis, my X bar is less than at 5% and 1% in both, right? So that means I will reject null hypothesis. Is this clear?
Yes.
Yes or no? So you can see option C and D are no, it's accept.
So reject is
So X bar is given as
opposite, no?
60, na?
See. No. So it's X bar is greater, right?
Yes.
So greater.
It's a greater than C. You can see. So X bar is 59.3. So 59.3 is greater than this part, and 59.3 is greater than this part also, right? So we will accept this. Okay.
So at first you just wrote that also we need to change sir. Like X bar is T is greater than C. At first you just wrote.
Where I wrote.
X bar is less than C.
Sir,
It should
X
be
bar
X bar
kitna hai,
greater
sir?
than C.
59.3, na?
Yes.
Okay.
See, X bar is less than C because my alternative is this, right? That's why we decided. Alternative is left side tail. Then we have decided this X bar is less than C. So if you are left tail test, you will reject.
I
Then
got it, sir. I got it. Really sorry,
okay.
sir. Okay, sir.
Okay, so let's do this question number 6, which is also important. So this is again, I will say this is again important. So this p value and all is very important for you. So question is, what is the scenario? Suppose a principal states that the students studying in her school have an average IQ equal to 98.5. Okay, a reporter suspects that the average may be higher, and took a sample of 100 sample students, 100 random students from that school, and found that average IQ score is
98.78. So what is this 98.78? This is X bar, right? Because this is based on sample. Assume the IQ scores are normally distributed with the standard deviation of sigma 1.6. So this is sigma and this is
Yes.
mu. So what will be null hypothesis and alternative hypothesis?
So null hypothesis will be mu is equals to 98.5 and alternative will be 98 greater than 98.5.
Greater than 98.5. That means option B is correct. Why? It's because what is the suspect? Reporter suspects that it may be higher, right?
Yes.
Yes, sir, because of maybe higher.
So if this is the okay, tell me if this is the case, when you will reject your H naught. So I am going to reject my H naught if
X bar greater than C.
T is X bar is greater than C or T is greater than C. Okay, so here if you see in the next question we have to calculate the P value. Okay, so actually P value is nothing but what? P value. Actually, P value is the lowest significance, right? We have to calculate the P value. We have to find that lowest significance value. Yes or no? So this is nothing but this is basically what is the alpha? Reject H naught when H naught is true, but we have to find the lowest, right? So lowest significance is the P value only, right? This is alpha only. So what is the meaning of lowest significance? How will you find the P? Actually, if you see the value of test statistic is greater than by what? 98.78. Yes or no?
Yes, sir.
Yes.
You are going to test for this. Okay, so mu is sorry, H naught is mu equal to 98.5. So you have to remember. So if you see what is this line, average IQ score of those children is 98.78. Okay, so what is the P value? If you see the P value, so this is the suppose C, this is C dash. So your test statistics should lie here, right? Right? Yes or no? This is the alpha and this is the alpha dash, right? So this alpha dash is the lowest significance value, right? When you will decide, so you are saying the test statistic is greater than C dash, right?
Yes, sir, T equal to T.
Okay. Now, so what is the T? T is nothing but X bar only.
Yes.
Okay, let's do like this. So can I do something like T minus expectation of T divided by standard deviation of T greater than 98.78? And what is the distribution of X bar? Tell me. What will be the distribution of X bar?
Normal of mu comma 1.6 square by 100.
Sigma square by n, right? Basically, it will be X bar follow normal mu comma sigma 1.6 square divided by 100, right?
Yes.
Okay. Now, the situation is to this will be expected value of T divided by standard deviation. Okay, I'm writing in general here. So mu is equal to 98.5. Okay. So this is nothing but G greater than 98.78. So expected value of T is again mu only, right? So minus 98.5. What is the standard deviation of this part? Okay.
1.6 by 10. 16.
6. Okay. So you are getting right. So whenever you have to ask the P value, you have to start this like this, probability of reject H naught, because this is the lowest significance. You have to find this P value. And in this case, what you will see, when you will reject, I'm going to reject my H naught if the test statistics is greater than that C dash, right? Okay. So I will check whether my test statistics is greater than this 98.78, then I will reject. Yes or no? Okay, that's what we have done. Okay, you can proceed. X bar is greater than 98.7. Understood? So here it will be probability G greater than. Anyone can calculate this value? Or
1.75.
1.75.
total probability this after dividing and all?
Yes, sir.
Yeah, 1.75. Greater than 1.75.
1.75. Okay, so I'm assuming this is the correct. So this is the P value. Okay, so this P value, what you have to do? 1 minus probability that Z less or equal to 1.75. So it will be 1 minus FZ of 1.75. So what will be the value of P value? So can I write FZ of 1.75 equal to Oh no, sorry, it's fine, right? So p value, so actually this value will be given to you, right? And you will subtract 1 minus something, you will get the answer. Okay.
Excuse me, sir.
Hmm.
A small doubt. Can you go up?
Okay.
Yeah, sir. Here T is greater than C, right, sir? And T is X bar. And we have given X
Oh
bar
no,
is
no.
98.78.
We have to find this p value.
Yeah, sir.
Okay, we have to calculate this value, p value. If you see the p value, what is the p value? P value is nothing but that test, this. Okay, you have to calculate the value of p, right? P value, basically. This p value is what? I will reject h naught if the value of test statistic, let's say p dash, is greater than some critical value, right?
Okay. Yes.
Okay, so okay, basically p value is nothing but it's the lowest significance. Okay, so lowest alpha, so you have to find lowest alpha when I'm saying this my x bar is greater than 98.78. Okay, it's not exactly 98, x bar is 90. So what you want to check whether your test statistic is greater than this part. Okay, so that's what you are doing in the alpha, right? If you see in the alpha, what we are doing, probability that I am going to reject h naught when h naught is true. Okay, so when you are rejecting h naught based on test statistics, you are saying x bar is greater than some critical value, right? So actually, if you see from the graph only, this is standard. So this, suppose this is C, and I will reject h naught if x bar is greater than some C. Now, in case of p value, what I'm saying, this is given to me 98.78 based on the sample. What I will do, I will check the lowest part. I will try to find this part. Okay, so basically what you have to do in case of p value, you have to start with test statistic. You have to check whether it's greater than this part or not. Okay.
Yes. Yeah, I've understood.
Yeah, just try to solve some question. Again, this is important. Okay.
Sir.
Hmm.
So in this question,
Hmm.
the p-value is coming out to be 0.40,
0.04.
0.04 something.
Hmm.
Now, what we'll do is we'll compare it with alpha value.
No, it's not. We are not comparing with alpha value. So you can see p value. Okay, what I'm saying, p value is what? Lowest significance. Okay, lowest alpha. Okay.
Yes.
So suppose alpha is, I mean, suppose here p value you got 0.04. This is lowest alpha, means what? I mean, at 4% you are going to reject your h naught when h naught is true. This is the meaning, right? In this case, alpha might be 10%, alpha might be 0.05, alpha might be 0.10, right? And this is the lowest significance. So if you have alpha, so what you will do, you will say, I'm going to reject, there is a 5% chance of rejecting h naught when h naught is true, right? And this is the lowest alpha. You are saying p value is 0.05, that means there is a 4% chance of making that mistake. Okay, this is the least value. Clear?
Yes, sir. Sir, in some questions, we directly used p-value rather than going for critical values, and then we compared it with alpha.
Yeah, that is a different. Don't worry, that's not come here. Okay.
Okay.
Okay, that is something you are talking about. P value is less than alpha, then
Yes,
reject,
sir, yes,
or
sir.
p value is greater than alpha. That's not here. Okay,
Okay,
we
sir,
can
okay.
discuss it later. Okay,
Sure, sure.
Okay, yeah, I got your point. Okay, so the next scenario is, tell me why option D is correct. So situation is, you have to consider this situation. You have to match with the suitable statistics and hypothesis.
So because variance is unknown, so
Correct. So if you see, samples have been drawn from normal, but variance is unknown. Then I will, okay. Why option test statistic equal to sample mean?
Because t-test we use in the hypothesis
No,
part we use mean only.
no. That is something you decided. See, variance is unknown. I can use chi-square.
But in chi-square we check the variance, right? We don't
That's
check.
what. So what is my question? How did you decide this is the sample mean? My question is this.
because in the question it is given, we want to check whether the mean is greater
Correct.
than.
Yeah, that is we want to check for the mean, right? If I
Yes.
want to check for the mean and variance, if see, first of all, you have to think like this. So there is, if you want to test for mean, so there are two tests, Z and T. Z test I will use when sigma square is known, and T test I will use when sigma square is unknown. Understood?
Yes.
Okay, what about this question?
So you have two IID samples, both are independent, and samples mean are denoted by X bar and Y bar. Okay,
Sir, it
and
looking like sir ape test.
tell me why. My question is why this option 2 and 3 is correct.
Because
Option
sir,
3 is correct because of definition.
Okay, and why option 2? This is also definition of chi-square statistic, right?
You have just
Minus
right
1
it.
s square divided by sigma
Yes,
square will follow
we have
chi-square.
considered only one sample in this case. Yes.
Okay. And why not option
don't
number 1? What is the
sir.
wrong? What's wrong with option number 1?
Sigma 1 square by n1 minus sigma 2 square by n2
It should be
It should
plus.
be
plus.
Plus.
Correct. So I told you that these kind of questions are important actually. This calculating p value, okay, just keep this mind, this starting steps, and this part while deciding on alpha and all. Okay, what if if question is about you to calculate the alpha and c is given to you, you can calculate, right?
yes, sir.
Yes, sir.
Okay. See, these kind of questions is very important. This part and. So one more thing you can keep in mind. So here, if you see, I was given the 16, right? Suppose this is not given to you, then you go for t test, right? So basically,
Yes.
option will look like 1 minus f t.
Tn minus 1.
Yeah, what should I write here? N minus 1.
99.
99. Okay, and something here. Understood? So these kind of things you have to keep in your.
Sir, why 99, sir?
N minus
Okay,
n minus 1 degrees of freedom.
n minus 1 degree. So if 100, so 100 minus 1, this is 99. Anyway, if you see the graph of t distribution, okay, if you see the graph of t test and g test, right, for large degree of freedom, okay, for large n, so it will be symmetric only. Basically, it will give you the standard normal curve. Why? Anyone, any reason? Can you think? Any idea? No? Any guess? Random guess or whatever?
No idea, sir.
No? Have you seen the central limit theorem?
So the variance would highly reduce. In this
What is
case.
the central limit theorem? For large n,
Distribution
any
approach.
samples, yeah, any distribution, any sample will converge to normal
Normal
distribution.
Normal
Okay. So for large, if you increase the sample size, if you n is large, then t distribution, binomial distribution, any distribution, irrespective of the original samples, I mean the samples which you had drawn from the original distribution, will follow normal distribution. Okay. Okay, that's the difference.
Sir,
Okay.
here, one question is here. When we calculating the power, 1 minus beta, here, but we are in this option, we are not like beta equal to 1 minus value. Why we are not doing like this?
Can you come again?
For calculating the power, the 1 minus beta equal to fz something. Okay. If we this is the option given, but suppose in my mind I also thought beta equal to 1 minus fzy. Can we calculate like this?
Yeah,
Here,
you
here.
can. You can. That's not a problem. You can. What is the issue?
Here.
You can. See,
Okay.
if you can.
Okay.
The only issue is, see, you will get the at the end final answer. So if you are doing 1 minus probability beta, you are saying rejecting H naught when H is true, right? If I am writing beta equal to 1 minus probability, rejecting H naught when H is true, okay, so what is the situation? 1 minus, what is this? If you are doing 1 minus probability of rejecting, so this is nothing but probability of accepting H naught.
Correct.
Correct?
Yes, sir.
Okay, so you can do like this also, but here you will get the value of beta. If you are doing 1 minus beta, that will give one rejecting. Okay.
The terminology is if we question asking power, that time 1 minus
1
beta.
minus beta, yes.
1
It's all.
minus beta.
Yeah, if it's
When
asking about type 2 error, probability of type 2 error, then it's a beta.
Okay, sir. Okay.
Okay.
Thank
So you can understand by the definition. So what is the power? Power means you are saying you have rejected the item given that item was bad quality, right? That is the power.
you. Yes.
Power means this would be high. Whenever if you calculate 1 minus beta, it will be very high. Means some, I mean, not like
5%, it will be 90, 95 or something like that, because they are saying it's a power. Okay.
Yes, sir. Thank
See,
you.
what is the, you are saying you probability of rejecting the product when it is of bad quality, means you have rejected the item which is of bad quality. That is something sure event. Okay. And probability of sure event is always close to 1.
1, yes, sir.
Okay. Yes, Praveen, do you any query?
Yes, it's related to a statement which Professor made in lecture 11.6. Uh, he said that as we keep increasing the value of t,
Huh?
we are not going to reject the null hypothesis unless our alpha is really really small. I think this statement is not correct because as he take an example in that. So if we in which mu equals to 2, and he was saying if test is statistics is the sample mean. So if we keep increasing the sample mean, means our mean value will also increases, and it deviate means if mean is 0, it's in this example. So if t is very large, then evidence against the null hypothesis become very strong. So why we do not reject the null hypothesis?
I'm not getting your part. Can you
He said
specify the exact part
Yes, sir.
on this
I
question?
also can't get his point. You
uh,
can you type in the chat box?
Chat
yes.
box, or Praveen, what you can do, as you have math session. So what I would suggest, you can tag me on Discourse. I will answer
I
that.
don't have any session. I have completed maths.
Okay, that's okay. Okay, okay.
सर
Then
सर वन मोर थिंग, ये जो एन टर्म का वेटेज है,
hmm.
ये सर 9 से वीक 9 to 12 में कितना परसेंट है, 70 या 60?
No, it depends. So you can assume approximately 60, 60, 40 something. Okay, but more weightage will be from 9 to 12.
Okay, okay.
Okay, okay. So that's all from our side. So Praveen, I think
So,
just tag to me on Discord.
sir,
Okay, I will.
I'm pasting its statement in the chat box. Sir. You can read
So
from
please
there.
upload the PDF. Huh?
Yeah, I will upload the
Okay.
PDF. Okay.
Thank you,
Sir,
sir.
sir, and
Thank you, sir.
sir, one more thing, sir.
Thank you, sir.
So,
Sir, hello, sir.
Yes, yes.
Yes, sir. Last of all, thanks a lot for supporting us continuously throughout this term, sir.
Yeah. Thank you. Thank
You
you. I
are
hope that all
you are
those.
you are a great educator,
Thanks. Yeah.
and a good instructor. You give us the hope to score good in statistics, and I hope
Okay. Okay. Thanks.
uh,
Thanks. Just the one thing I can say.
instructor like you should join this course more, because the instructor will help us a lot in our preparation.
yes,
So
sir.
in
Great.
all subjects
That's
in
the
future, we if we get mentors like you, it will help us a lot.
great. Great. Thanks.
So, sir,
Thanks. Thanks for this.
और सर आने वाले समय में डिप्लोमा लेवल या फिर डिग्री लेवल में सर क्या फिर से आप हमारे साथ आएंगे कुछ?
So degree level में मेरे courses है statistical computing and linear statistical model. Planning for some diploma level courses in maybe upcoming term, but I'm not sure about next term only. But I'm handling 2 courses in degree level also. Okay, so that's called linear statistical model and statistical computing itself. Those 2 courses we are handling.
You are instructor there?
Yeah, I'm instructor there for these 2 courses and here.
Okay, okay.
Okay.
आपका सर प्रॉब्लम सॉल्विंग स्किल बहुत बढ़िया लगा मुझे.
Okay, so okay, first of all, thank you for this. The one thing I can say, that's from our side, it should be helpful for you, right? So if you have learned something from our side, that's can say that's our agenda. That's our then we are success. Okay, that's
So, would you mind reading my statement? Start reading.
yeah. So I will see. Okay, so that's all for everyone. Okay, Praveen will discuss this part. Okay, so that's all, everyone. Thanks all. You can drop the session. Okay, so I will stop the streaming. Praveen, we will discuss just now. Okay, that's not problem. Okay, yeah.
Thank you, sir. Good night.
Okay, thank you. Bye.
Have a
Good
good
night.
day.
Yeah, good. Thank you. Okay, so you're saying this statement true, the value of t that you get, the sample mean that you get in this case as key